All right, today's lesson is 1.4. Here's your warm-up, so go ahead and pause the video and write each of the 3 problems on your bell worksheet, and then come on back as soon as you're finished to see if you did it right. Okay, from last week's lesson, we learned that parallel lines, and these lines are parallel because of the little arrow markings here. Parallel lines create special angle relationships. So you have to kind of remember that it's going to create, you have 2 angles, that 2 angle measures. One's going to be obtuse and one's going to be acute. So either the angle measures are going to be equal to each other, or if I have one of each angle, one acute and one obtuse, they're going to be equal to 180. So looking at these 2 angle measures, I can see that this one is obtuse and I can see that this one is acute. So clearly that they are going to be the linear pair relationship, where when I add them together, I get 180 degrees. It's not plus 24, it should be minus 24. And you could go ahead and solve for x and find the measure of each angle. Second example, again, my lines are parallel because of the angles. In this angle pair relationship, those are called vertical angles from last week. 2 intersecting lines that make angles, that create angles opposite each other, are vertical and they are congruent to each other. So your equation should look like this. And then you could go ahead and solve for x and finish it up. All right, last example. 2 parallel lines. So these are my parallel lines cut by a transversal. Need to know the relationship between this angle right here and this angle right here. Okay, so they are both on the outside of the parallel lines and they are on opposite sides of the transversal. So that makes them alternating exterior angles. And alternating exterior angles are congruent. And you can go ahead and solve for x and find the measure of each angle. All right, there's your table of contents. Please take a moment to write that in your notebook. And we're going to be focusing on that word converse, so make sure you underline or highlight that in your notebook. All right, so we've actually been using converses before when we were talking about midpoints and bisectors, angle bisectors and segment bisectors, but we never really called it a converse. So the concept behind a converse is really simple. There's 2 different types of theorems, which are things that we have to prove: direct theorems and converse theorems. So here's an example of a direct theorem right here. If M is the midpoint of AB, so if M is the midpoint of AB, then AM has to be congruent to MB. Okay, well, we know that. We learned that in the first unit. The converse of that says that if AM and MB are congruent, so if these are congruent, then M is the midpoint. So it just says the same thing, but in reverse order. So that's this principle we're going to use to talk about parallel lines and angles today, because they have a similar converse relationship as the midpoint example given here. So last week we learned that if 2 lines are parallel and they are cut by a transversal, that the corresponding angles are congruent. Today we're going to learn that if the corresponding angles are congruent, then the lines are parallel. So all 4 of these examples are going to have a converse, and that's what our lesson is going to talk about today. All right, corresponding angles. You don't have to write the direct statement, but I would definitely write from the yellow line and below. So you're writing everything in this area right here. All right, take a moment and pause. All right, again, you're responsible for this area right here. So we're talking about the converse of alternating exterior angles, saying that if 2 alternating angles are congruent, then the lines are parallel. All right, alternating interior angles converse. Go ahead and take a moment to pause the video, and again, you're responsible for the yellow line down. If the alternating interior angles are congruent, then the lines are parallel. Last one, consecutive interior angles converse says that if two consecutive angles add up to 180, or in other words, they're supplementary. If they add up to 180, then the lines are parallel. All right, take a minute to review your notes. What is a converse? Take a minute to review your notes and see if you can name all four of the angle converses without looking. All right, here's some examples of how we're going to put this to use. So I have this image in problem number 1 where it shows me an angle down here. I'm trying to prove that the lines are parallel, that U and V are parallel. So they give me this angle of 130 right here, and they're giving me a big question mark here of what must that angle measure be if I want the lines to, or if the lines are going to be parallel. Well, we know that these are called corresponding angles, and so that would answer that question. And are corresponding angles supposed to be congruent, or are they supplementary? All right, so let's talk about that for a second. This is an obtuse angle. This is also an obtuse angle, so I'm going to say that they have to be congruent. So that angle measure would have to be 130 degrees if the two lines were going to be parallel. Similar situation in problem number 2. I've got this angle right here and this angle right here. I need to know what angle measure would that question mark have to be if the parallel lines were going to be, or if the lines were going to be parallel. Well, those are alternating interior angles, and those also have to be congruent. And if you look closely at the diagram, I can see that this is an obtuse angle as well as this, which means they would have to be equal to each other, so this one also has to be 128. All right, find the measure of the angle that makes U and V parallel. All right, so I've got this one right here, 66-degree angle, and the question mark goes with this angle here. All right, so those are, in case you didn't guess it, alternating exterior angles. So they're alternating exterior angles. All right, so if this is 66, let's look at the angle size here before we go any further. So that's an acute angle. This is also an acute angle, which means this also has to be 66. So if they were both 66, then the lines would be parallel. All right, last one. So they gave me a different situation here where I have two angles on the inside of the lines, and those are called consecutive angles. Okay, what would the measure of the question mark have to be if the angles were going to be, or if the lines were going to be parallel? Well, I would say that if this is 80, since this is a line, that would have to be 100 degrees. Then I could call these consecutive angles if I wanted to, which means this would also have to be 100 degrees. And if they were both 100 degrees, then the lines would be parallel. All right, is it possible to prove that lines A and B are parallel? All right, we kind of have to start thinking about your angle pair relationships, and there's a couple of ways that you could do this. I think by far the easiest way would be to look at this relationship between these two right here. If this is 100, then this has to be 80. And then I could go even further and say, well, if this is 80 and this is 80, then they are both alternating interior angles. And since they are congruent, yes, the lines are parallel. I can prove it. Is it possible to prove lines E and F are parallel? All right, well, I've got this transversal, These are my two parallel lines, so they're just trying to confuse you with this drawing a little bit. They just split this angle into two pieces. But 80 plus 30 is 110, and this angle, the other alternating exterior angle, is also 110, which means the lines are parallel because of alternating exterior angle converse. Since the angles are equal to 110, the lines must be parallel. All right, here comes the algebra. Find the value of x that makes lines U and V parallel. All right, so let's see what kind of angles we're talking about here. I think these are called, in case you didn't guess it already, they're corresponding angles. And it looks like they both have the same measure, which means they would have to be equal to each other. And then you could go ahead and solve for x and find the measure of each angle. Find the value of x that makes the lines parallel. All right, so similar situation, except I've got a different angle pair relationship here. I've got alternating exterior angles, so this would be the alternating exterior angle converse, saying that if I can find a number to plug in for x that makes the angles equal to each other, then the lines will be parallel. So I have 105 is equal to x plus 112. And then you could solve for x and find the value of x that makes that happen. So it looks like x is going to be negative 7. So if x was negative 7, then the lines would be parallel. All right, course, let's see, the value of x that makes U and V parallel. So I'm not talking about this line, it's not even really in the picture, so I'm just going to pretend it's not there. All right, so I have these two angles right here, and those are alternating interior angles. Okay, and looks like they should be congruent to each other. They're both acute angles, so I could set 8x plus 6 equal to 7x plus 14, and then solve for x and find the measure of each angle. All right, little review of proofs from last week. So go ahead and copy this down in your notes and see if you can get through the logic of it, and that will be a good example for you to keep. All right, this one also goes in your notes, given that G is parallel to H and angle 1 is congruent to angle 2. So let's write that. Given is G parallel to H, and angle 1 is congruent to angle 2. All that was given to me. And let's see, what can I conclude from that? If G is parallel to H, which is already labeled over here, I could also say that angle 1 is congruent to angle 3 because they are corresponding angles. So angle 1 congruent to angle 3, corresponding angles. All right. Now I've got three things that are all congruent. I have angle 1, angle 2, and angle 3 are all congruent. So since this, hold on a second, let me change color here. Since this and this are true, it must also be true that angle 2 is congruent to angle 3. And if you remember from last week, that is the transitive property. Okay, so if angle 2 and angle 3 are congruent, I can now say that P and R are parallel because of the converse of alternating exterior angles. 3 and angle 2 are congruent and alternating exterior. So I'm going to say P is parallel to R, converse of alternating exterior angles. Okay, that's your proof. All right, homeworks 3.4 and 3.5 are due tomorrow, and don't have a panic attack. They're each only one-sided, and I couldn't see the difference or the reason that the district had split them into 2 assignments, so I'm just going to assign them both, and they are both due tomorrow. So hope you're having a nice day at home, and I hope you feel better. See you tomorrow.